Hey there, YouTube. So this is the DPS30V12A, which is a 30 volt, 12 amp power supply from RD Technologies. I believe it's the same user interface. You power it up and everything. It's just the little sort of terminal block. It's fairly empty except for your two fairly big headers, which go to ribbon cables, which go over to this board, and you just pop off this little backing, and then it's got the two things which are labeled in the silk screen. One is LCD and the other is key. So make sure you put them in right, because you might break something. You don't want to be sending like 5 volts to the LCD when it's only asking 3.3, or I guess vice versa might not be too bad. So yeah. Yeah, here it is. I guess I just want to give a quick fire up. I've got this big old 12 volt motor from a golf cart pusher. Not golf cart pusher, but a golf bag walker, where you hang your golf bag from it and you turn it on, spin the knob, and it walks your golf bag for you. Yeah, people are lazy. It's pretty old. I had to snip the battery connector off of it, but I have both sides. Otherwise there wouldn't have been a way to get the box out without popping it open and pulling everything out. But yeah, it's just a little PWM controller with a single transistor. Pull the motor to ground. It's got, and yeah, uses a fair bit of power. So we'll see just how much power it uses. It's got the 3 wires going to here to a little stereo jack, 1/4 inch, but didn't have the blue wire connected. Seems like they just used a mains cord. You got earth, neutral, and hot, which is kind of hilarious. So yeah, I've got that set on a potentiometer so that I can put it all the way to stop, whereas if you don't have the ground, it only goes to very slow. But anyway, let's see what it's set at. 12 volt, 5 amp, which I can't do any more than 5 amps, otherwise I will overload the wattage on the power supply that I'm using. It's only a 65 watt Dell supply, so don't want to trip that out, make something bad happen. Should just turn off, turn back on, but never can be too sure. It might put this guy in a sideways state. So yeah, power it up. Boop, there you go, 12 volts, 002 amps, so 20 milliamps or thereabout. And yeah, so now that that's on, I will spin the knob and yeah, this guy uses some power. That's why I have these SLAs sitting here. There we go. 12 volts, 240 milliamps. This is about 4 amps unloaded, but if I, yeah, basically limits the current there. Yeah, you can see I'm pushing 60 watts there. But yeah, let's change the voltage, shall we? So we're in 0.1 volt. It's weird, it's still using like 3 amps. It's down to like 9 volts. Well, there you go. So yeah, that's that. And then we power it off and take a look at the board. So this guy, it's got the input and the output both have, well, inputs on the left, outputs on the right. Same as a lot of the other power supplies. I know if you see Julian, he reviewed the other ones. Some of the ones that are on eBay and stuff. Basically the same thing. Not quite as beefy as this one though. I'm sure, I think these are like pretty much the most compact that you can do. As far as delivering pretty high current as well. So yeah, you've got the 2 positives and then it's broken to the 2 negatives. So it's not exactly compatible with the other models, as the positive, then the negative, then the negative, then the positive. So not quite the same, so you can't like pot swap the power supplies between the two, but yeah, it is the exact same connector block, same as the other. Actually, let's get a look at what that connector block is. You can get the shine there. There you go. These are 300 volt, 10 amp, 22 to 14 gauge wire. And it's got 4 conduits, so I think that's 10 amps per channel, basically. So let me pull off the output terminal. Yeah. There we go. And then let me unplug the... Alright, I'll be back. Okay, I tore it to bits. So, like I said, it uses those about 6-7 inch, probably like what, quarter meter or something like that, ribbon cables to go from here, which is literally just the buttons and the LCD. Looks like they use the same 2x4 header as they did on the other ones. And then you've got LCD, and then you've got your key ribbon cable. And I don't think there isn't anything besides maybe some passives for the rotary encoder and the buttons. Everything else is done on this board, which is the main board. So it's all included into one big board. Plastic standoffs, which I guess are probably cheaper than the metal ones, which do basically the same thing. Makes it lighter too. But there you've got your key on the right, then you've got LCD on the left. So you've got your main input terminal, which you view the bottom side. But your 6 capacitors on your input and then your output. You've got the 2 MOSFETs and then the heatsink screwed down. It looks like you've got a separation plane between one side and the other, which are joined right here. Looks like it's right at this current shunt. Yeah. That's interesting. It looks like the top side of that joins down to the bottom side. That's interesting. Very interesting. Yeah. That must be something to do with separating everything. So that way I don't know which is separated from what. I haven't done like continuity tests and low ohms tests. Not yet, but let's see, we've got, it's starting over here at that current shunt. We've got a little two guys here. Looks like a transistor Q02, and then you've got U3. So A63A is U3, and then you've got another little thing there. That's probably some sort of ADC, analog to digital converter, whereas the other one is one of those current adjustable gain current amplifiers. You got Alex. So this guy, he's the main microcontroller. He is a 32F100 C8T6B or 8 GH224. So some little Atmega processor, something like that. ST, so Silicon Technology or something. And then we've got this other guy here. Let's zoom in, shall we? And we've got a DP30V5A, which is, that's kind of interesting. So no other markings. Oh, there's that transistors. That guy. Get him into focus. There you go. That little guy. So yeah, that looks like a custom chip. It's like he's designed his own chip for the 50V5A model. And there it is right there, implemented. I didn't really see that on this thing. Let me just have a quick look again. No, yeah. There it is. Right there, if you can see. Right there, you barely see it. Right there. That's the 16 pin chip there. It's the same. So yeah, that's kind of cool. Made his own chip. Pretty ingenious of him. So that's probably what powers a lot of the ADC, MOSFET controlling, and just general buck converter stuff. So it's probably like a programmable buck converter, which relies on some of the other stuff to take the parameters of. So yeah, that's pretty cool. And then you've got some of the other little chips. Looks like, so this is the main input here, positive going over. So this looks like a buck converter. Yeah, it looks like a MOSFET there, double MOSFET. And then, let's see, tiny little guy there, that must be another buck converter chip. And then you've got, looks like 2 linear regulators here. These are STK17 and then 7133. Yeah. And then you've got that tiny little guy. Focus in, get some good light. B6286 B6296 or 286. You got a little MOSFET, and you've got this guy here. Can't get good light on it, but MCP60021. MCP, I remember that. That's some sort of some sort of something. Yeah. Let's see, you've got your big, so this is the diode for the buck converter, and then the transistor for the buck converter, BNP transistor, and then diode from ground. Got a large power resistor, 2 transistors, 2 diodes. Looks like another diode. Then on the back here of the heatsink, we've got a little fan, probably a little 12-volt fan, or 5 volts running off of one of the system rails. I'll have to pop that open, see whether it is or not. Pop that off the heatsink. Plugs in there. I think there's a little transistor in there. If you can see it or not. There you go. Tiny little guy next to the pin. So yeah, that's kind of it. Let me see if I can get that fan. Alright, there's a little fan. And it is a Pengda technology 5 volt DC. Doesn't say like current or anything, but probably like 100 milliamps or something. And yeah, here's the heatsink. Yeah, it just kind of screws in there between the fins. So yeah, whoops, dropped one of the screws. So yeah, that is the DPS 3012, 12 amp, 30 volt. Don't have the specs. Let me see if I can grab those real quick. There you go, there are the specs. 6 to 40 volts. 0 to 32 volt output. And 0 to 12 amp. So, yeah. So 40 volts on the input. I'm planning on using 2, well, this won't be it, but it will be the 290 watt Dell power supplies. Thanks for watching.